Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on the Cambridge IGCSE for Mathematics Paper 4, the extended paper, for October/November 2023. By the way, this is the 4-3 variant. Let's start. Question 1. The table shows the amount received when exchanging $100 in some countries. A. Brad changes $250 to Indian rupees. Calculate the amount that he receives correct to the nearest rupee. So $100 becomes 7437.05 rupees. So $250, this is 2.5 times 100. And why we do 2.5 times 100? We know how much is $100 in rupees. So to find 250, we just do 2.5 times the value for $100. So the amount he receives is 2.5 times 7437.05. And getting a calculator out, we will get 2.5 times 7437.05 to get 18592.625. And that's simply going to be 18593 rupees to the nearest rupee. That's our answer. Let's go to part B. Wang changes 5,400 Chinese yen into dollars. Calculate how much he receives in dollars to the nearest cent. Alright, so we know how much is $100 in yen. So we can find how much is $1. By the way, the similar method could be used for the previous question as well. I'm just showing both of the methods. So $1 is going to be equal to 671.20 divided by 100, which is 6.712 Chinese yen. And now the amount of dollars which he will get is 5400 divided by $1 in Chinese yen. That's simply going to be, using our calculator once again, $804 and 53 cents, since we have to give it to the nearest cent. 804.53. By the way, cents are in the hundredths place, or 2 digits after the decimal point. That's the answer. Let's go to part C. Gretel lives in Spain and goes on holiday to the Wales. She spends 3,500 euros in total on travel and hotels in the ratio of travels to hotels equals 4:3. 1. Work out how much Gretel spends in euros on travel. So this 4:3 is a total of 7 parts. And the amount that Gretel spends out of these 7 parts on travel is 4 parts. So 4 out of 7 parts. This can be written as a fraction, 4 by 7. Right? So 4 by 7 of the total, 3,500 euros, is going to be 2,000 euros. That's our answer. Let's go to part 2. Work out how much she spends in pounds on hotels. Well, we know that hotels is 3 parts out of a total 7 parts, and that's just 3 by 7 of the total 3,500, which is equal to 1,500 in euros on hotels. Now, what about pounds? Remember that they've asked us for the total amount of pounds which he spends, not the euros. So you have to convert euros to pounds. Now you can see that $100 is 85.35 euros. So that means $1 is 0.8535 euros by just dividing both sides by 100. So 100 by 100 is 1, and this by 100 is this. Now the amount of dollars which he spends is going to be 1500 divided by 0.8535. And that is going to be, getting our calculator out, 1500 divided by 0.8535. That's 1757.47 pounds. That's our answer. By the way, even if you don't know the actual symbol for pounds, of course, it's fine. You just need to write the number. It doesn't matter if you know the symbol or not. Now let's go To part 3, Gretel flies home to Spain. The plane flies a distance of 2,200 kilometers, correct to the nearest 100 kilometers. The average speed of the plane is 740 kilometers an hour, correct to the nearest 20 kilometers an hour. Calculate the lower bound of the time taken in hours and minutes for this flight. So first of all, we know that the equation for speed is distance by time. Now we can rearrange this to make it time is equal to distance by speed. Now to get a lower bound of time, what do we need? On first sight, it could look like you just need to take the lower bounds of these two, but that is wrong. You must take the lower bound of distance and the upper bound of the speed. Why? Let's take a simple example. Let's say distance is 2 kilometers and speed is 3 kilometers per hour. Now, if we increase the speed to 4, then the time taken will be 2 by 4, and this is less than 2 by 3. Even though we increase the speed from 3 to 4, the time taken decreases. So of course, the speed should be as high as possible, or the upper bound, and distance of course should be a lower bound, since less distance obviously means less time. So this we take the lower bound, this we take the upper bound. Now the lower bound of the distance, 2200 kilometers is correct to the nearest 100 kilometers. A nice trick you can use is the lower bound of the distance is equal to the rounded value, or in other words 2200 here, minus the rounding value, or what we round to, in this case nearest 100, divided by 2. And if this was the upper bound, we would just make it plus. That's the only difference. Now that's 2,150 kilometers. Now the upper bound of speed is going to be 740 plus 20 by 2, which is 750 kilometers. So the lower bound of the time is going to be 2150 divided by 750, which is, getting our calculator, 2.87 hours. And multiplying the remaining decimal point by 60, it's 52 minutes. Even if you don't subtract 2 at the start from this, if you multiply it by 60 straight away like I did, then you have to subtract 120 minutes, which is the same thing as 2 hours, to get the minute values, and the 2 hours will be added on later. So that'll be our answer, 2 hours 52 minutes. By the way, if you notice that the number is 2.87 here, but then in the calculator we're showing 2.8666, yes, that's true. But then I just wrote it like this because I write 3 significant figures. Although I did not use this value for the calculation, I've just written it like this. That's our answer. Let's go to question 2. The table shows the number of each type of bird seen in the garden on Monday. The type of bird, frequency, and pie chart sector angle are given for 4 different birds: the goldfinch, jay, starling, and robin. A. Find the percentage of birds that are starlings. So the percentage which are starlings are going to be 11, which is the frequency for starlings, divided by the total frequency, which is 30, by adding all those values up, and then times 100% because it's a percentage. And when we do this calculation, once again using our trusty calculator, 36.7% to 3 significant figures. That's our answer. Let's go to part B. 1. In the table, complete the column for the pie chart sector angle. In this case, the goldfinch, which has a frequency of 8, has a pie chart sector angle of 96 degrees, because 8 by 30 times 360 degrees is 96. Now, for the rest of them as well, we just divide by 30 and multiply by 360. And dividing by 30 and multiplying by 360 will cancel out to just multiplying by 12, right? Since 360 by 30 is equal to 12. So just multiply all of these by 12 to get these sector angles. And that's our answer. Part 2. Complete the pie chart to show the information in the table. Well, I do not have an actual protractor with me right now, but then I can show you how you're supposed to do this. So the goldfinch has already been labeled 96 degrees here. Now for the J, it's 72 degrees. So we place a protractor such that the horizontal line at the bottom, which is marked by the protractor, is lined up with this. And then we mark where 72 degrees is going to be. It'll be around here. And we can draw a line from the center of the pie chart to that point and then just label this as J. Now for the starling, we do a similar thing. Place the protractor such that the horizontal line lines up with this, and then calculate 132 degrees using the protractor. Just place a dot, connect the line, and I'll just do that real quick. Now we just write starling. And we could do this with the last one, but we realize that when we do this process, when we calculate 60 degrees, this line here is going to be the final line drawn. This point we will get and we drew this line, so we don't need to draw that again. Therefore, whatever is left is just the robin. That's our answer. Let's go to question part C. On Tuesday, the number of goldfinches seen in the garden increased by 262.5%. Calculate the number of goldfinches seen on Tuesday. So first of all, an increase of 262.5%, it means 262.5 plus 100, 362.5% of the original. Now let's go back and see how much goldfinches were there on Monday. 8. So 8 times 362.5 by 100. Since it's a percentage, we divide by 100 and getting a calculator out. 8 times 362.5 divided by 100, 29 goldfinches, which is our answer. Now for part D. One of the most common birds in the world is the red-billed Kela, which lives in sub-Saharan Africa. There are approximately 1,500 million of these birds in the area. 1. Write 1,500 million in standard form. That's just 1,500 followed by 6 more zeros, since a million means 1 times 10 to the power of 6, or 1 followed by 6 zeros. And this is going to be 1.5 times 10 to the power of 9 in standard form. This was quite straightforward. That is our answer. Part 2. The land area of sub-Saharan Africa is approximately 21.2 million square kilometers. Work out the average number of these birds per square kilometer. So 21.2 million is just 21.2 times 10 to the power of 6, because a million is 10 to the power of 6. And then the average number of the birds per square kilometer is going to be 1.5 times 10 to the power of 9 divided by this value here. So that means we'll get the amount per square kilometer, because this 1.5 times 10 to the 9 is the amount inside all of the area of sub-Saharan Africa. So therefore, we can just cancel this and we'll get 10 to the power of 3. And we get 1,500 divided by 21.2. And using our calculator, here we go. 1500 divided by 21.2, which is 70.8 birds per kilometer squared. That's our answer, 70.8. Now let's go to question number 3. Question 3. A. Describe fully the single transformation that maps triangle A onto triangle B. We can see that triangle A and B are the same shape, just with different orientations. So of course, this is a rotation. Now, what are the two main things we need to keep in mind when we have a rotation? One is the angle of rotation. In the syllabus for extended maths is usually 90 degrees or 180 degrees, and this 90 can be both clockwise or anti-clockwise. And 180, it does not matter if it's clockwise or anti-clockwise, it'll still be the same thing, 180 degrees. So in this case, if we visualize turning shape A around until we get something like shape B. So the fastest way to do it is by turning anti-clockwise. And how much? If we think about it a bit, this vertical side is becoming horizontal after you finish the rotation. So how does vertical become horizontal? 90 degrees. So it's a rotation of 90 degrees anti-clockwise. Another way you could think about it is that the two corresponding sides are perpendicular, have a 90-degree angle between them, so it has to be a 90-degree rotation. And now the second thing you need to remember is the center of rotation. And for this one, you need to do a bit of testing out with corresponding points and just giving a guess on where the center of rotation would be. First, let's see the general area. So we take these two corresponding points. We know it's a 90-degree rotation anti-clockwise, which is this direction. So the center of rotation will be generally around here, somewhere there, right? Now let's just try a few points in this general area and just see which works. So doing that, we will get this 0.2, 7. And this is 6 units to the right and 1 unit above our corresponding point for triangle A, and is 6 units above and 1 unit to the left of that same corresponding point on triangle B. What's the similarity? It's both 6, 1. The difference? The direction. The direction is just the 90-degree rotation of this anti-clockwise. So, by the way, a better method of thinking of that is going right and down, because then if you rotate this 90 degrees anti-clockwise, you will get these directions. Therefore, this is actually our center of rotation. Yes, it is quite tricky. You have to do a bit of trial and error for this. But then once you get down, it's much easier to do it, especially after you've done a few questions with similar ideas. You will start to intuitively feel which point is going to be the center. And of course, your visualization of these rotations will improve drastically. So yeah, center is 2, 7. That is our answer. B. Draw the image of triangle A after 1. A reflection in the line y equals 1. What is the line y equals 1? The line y equals k, where k is any number, a constant in mathematical terms, is always a horizontal line passing through the point 0, k. So in this case, it passes through 0, 1, and it's a horizontal line. So it goes like this. The line x equals k will pass through k, 0 and is a vertical line. But we do not really need that right now. Just for your information, I've said that. Now, the reflection of A in this line y equals 1. Just take each point and reflect it across this line, like you would do normally. Just think of this line as a mirror line, and all of a sudden things become quite easy to visualize. Especially once you've drawn the final diagram, it'll look quite neat, like a mirror line should look. Of course, use a ruler to draw this. Don't just draw random wavy lines, that will lose marks. Make sure these two are almost as accurate as you can get for this to be a mirror line. That's what a reflection is. Now for part 2, a translation by the vector 5 minus 7. This one's much more straightforward. The vector 5 minus 7 is just 5 on the x-axis and minus 7 on the y-axis. On the x-axis, a positive number means to the right, so you go 5 units to the right. And on the y-axis, a negative number means down, so 1, 2, 3, 4, 5, 6, 7 units down. that goes there. So this point of triangle A is translated all the way down here after you do that. So that means the other 2 points, you can do a similar thing to get one here, and you'll get the other one here, and you can complete the triangle like that. Or you can just find one point like this one here we got there, and now you know the shape of the triangle is going to stay the same. So you can draw that same shape with the exact same lengths as the original triangle, or actually any shape as long as it's the same as the original shape, and we will get our answer. So over here, this will be our answer. This is part 1, this is part 2, and now moving on to part 3. An enlargement scale factor 2, center minus 4 comma 5. Let's label that point minus 4 comma 5, of course. So that's over here. Now we have to enlarge this shape A with this as the center. And of course, scale factor is 2. What does this mean? Scale factor 2 basically means the new triangle or a new shape is going to be twice as large as the previous shape. So its lengths are going to be 2 times what they are here. This length will become 6, this will become 2, and this we can just connect the other 2 lines to form that one. If you really wanted to, you can use the Pythagoras theorem and calculate that, but it's not very necessary. The main thing you need to know is, using a center of minus 4 comma 5, let's take each of the vertices of the triangle. Let's take the first one up here. There's a distance of 1 unit in the y-axis from the center, right? Now, because it's a scale factor 2, just take 2 units. 1 times 2, 2 units from the center in the y-axis. So this is a new point. Now this is downward by 2 units. So the new one will be, of course, downward by 4 units. And now, for this point, this is right 1 unit and down 2 units. And this is in the original shape from the center. So a new shape will have right 1 down 2 and right 1 down 2 again. We have to do it twice. So that'll go over here. And then we just draw these lines through. This will be our answer. Part 3. The only reason I didn't draw this is because technically it's already there. But the best thing you can do in the exam is to just shade this a bit thicker than the previous one, so you know that there's a line drawn there. And that'll be our answer. Now going to question 4. A. Find the size of one interior angle of a regular 10-sided polygon. We have a formula for this, which makes this question quite straightforward. So the sum of these interior angles is going to be equal to 180 times n minus 2, where this n value is the number of sides of a polygon. So in this case, it's going to be 180 times 10 minus 2. Now doing this is just 180 times 8, which is 1440 degrees. Now, one interior angle is going to be the sum of interior angles divided by the number of sides, which is 10 here, so it's just 144 degrees. And this will be our answer. Now we can go to part B. The points A, B, C, D, and E lie on a circle. FG is a tangent to the circle at D. EB is parallel to DC, shown by these little arrows over here. Find the value of each W, X, Y, and Z. Let's see which ones we can get using just one theorem or one circle geometry law. Of course, why am I saying circle geometry? Because we have a circle here, of course. So the angle W we can get very easily because we know the alternate segment theorem. It is just 20 degrees. This angle is between a tangent and a chord on the circle, and we know that this chord splits the circle into 2 segments. This tiny one here and the huge one over here, which is almost the whole thing of the circle. So the tiny one is the minor segment and the larger one is the major segment. So the angle between this chord and this tangent here is the same as the angle in the alternate segment, which means we have a chord, right? So the angles, any angles subtended by this chord are also the same angle, 20 degrees. In this case, W. And of course, this X angle is also subtended by the same chord. So using the fact that angles subtended by the same chord are equal, this implies X is also equal to 20 degrees. Alternate segment theorem, I'll just write it as AST. Now we know W and X. The other two angles require a bit of working. Well, we know that this angle DAC is 25 degrees due to that same petty alternate segment theorem which we discussed just now, except we're doing it with this chord, this angle here, and the angle subtended by the chord is the same angle, 25. Now, the information of parallel lines helps us tremendously. This angle over here is going to be the same thing as this angle because they are alternate angles. Parallel lines help us confirm this. So this is also going to be W, which is 20 degrees. Now we have 25, 75, 20, and Y. How do you make sense of these angles? We see a triangle ACD. All these angles added up is equal to the sum of angles of a triangle, which is just 180. And therefore, Y can be found by subtracting 180 minus all of these angles. So the angle DAC is 25 degrees from the alternate segment theorem, and angle BDC is equal to 20 degrees due to alternate angles because of the parallel lines we found. Therefore, this angle Y is going to be equal to 180 minus all the angles we have, 25, 20, and 75 inside this triangle, and therefore we get 60 degrees. So W and X are 20 degrees and Y is 60 degrees. Now one more angle is left. Of course, it's angle Z. Well, this one requires a bit of visualization to do, a bit of imagination. So we have not used this angle 75 degrees at all. And one trick you could use for this question is that almost all of the time, everything given in the question is required to find some angle. So here we have a 75 degrees. We can use this because we have a cyclic quadrilateral involving this angle. And opposite angles in a cyclic quadrilateral add up to 180 degrees. So this angle AED and angle ACD add up to 180 degrees. So angle AED is just 180 minus 75. Simply 105 degrees. We have 105 degrees there. Now because we know X, which is 20 degrees, we can find the value of this angle ADE over here. And this is just going to be 55 degrees. And the reason why this is very helpful, give me a second, I'll just write the angle here for some clarity. The reason why this is very helpful is because now you have a triangle BED. And we know our Y angle, we know our W angle, we know that there's 55 degrees from what I showed right there. So using the sum of angles in a triangle, we can get Z. So Z is equal to 180 minus 55 minus W minus Y. We know what W is and what Y is. So 180 minus 55 minus 20 minus 60, which is 45 degrees. And we have got our fourth and final angle for this question. That's our answer. Let's go to question 5. Question 5. Indira records the time taken for workers in her company to travel to work. The table and the histogram each show part of this information. The time in T minutes and frequency are given, except for two of these boxes. A. Complete the table and the histogram. You know that frequency density is equal to frequency dividing by class width. So in this case, the frequency is just the class width of this one, which is 10, times the frequency density. And for 0 less than t less than equal to 10, it's 2.8. So 2.8 times 10 is just 28 frequency. Now for this class width is 15 and frequency density is 3. 3 times 15, 45 is our frequency. Now you have the two frequencies. Now you need to find frequency density for these three. Now that's going to be frequency divided by class width. So this one is 2.8, this one is 3, we know both of them. Now this one, 25 less than t less than equal to 40, has class width of 15. And 57 is the frequency. So when we divide that, we get 3.8 as a frequency density. Now for this one, 38 is our frequency and class width is 60 minus 40, which is 20. So 38 divided by 20, 1.9. Now this one is 12 divided by 80 minus 60. 12 by 20, which is 0.6. And these will be our answers. We just draw the graph of the histogram. So 25 to 40 is 3.8 frequency density. So we can draw lines up to 3.8 like this, and then coming down at 40. Now from 40 to 60 is 1.9, so you can draw lines like this as well. 60 to 80 is 0.6, therefore we get this. And this will be our answer. Part B, calculate an estimate of the mean time. The mean time is just going to be the sigma or the sum of fx, which is frequency, times the midpoint x of the class divided by the sum of the frequency or total frequency. So we can find the midpoint of each class. 0 to 10, we just add 0 plus 10 divided by 2 to get 5 midpoint. This one, 10 plus 25 divided by 2, 17.5. And do the same thing for the other three. We get 32.5, we get 50, and we get 70. So sigma fx by sigma f, in this case, is going to be 5 times 28 plus 17.5 times 45 plus 32.5 times 57 plus 50 times 38 plus 70 times 12. And divide all this by the total frequency, which is, when we add all of this up, 180. Now we can use a calculator. Here we go. 5 7s 28 plus 17.5 times 45 plus 32.5 times 57 plus 50 times 38 plus 70 times 12. 5520 divided by 180 to get 30.7 minutes. 2 3 significant figures. That's our answer. Now we can go to part C. Rashid says the longest time that any of these workers take to travel to work is 80 minutes. Give a reason why he could be wrong. Well, we know that the highest value lies somewhere between 60 and 80, but it does not have to be 80. There could be nobody with the time t minutes of 80 minutes. There could be someone with like 79, and that's the highest, but it does not have to be 80. There's no guarantee. There is no guarantee that the highest value is 80 or anywhere else where 60 less than t less than equal to 80. So we do not know which one of these values is the maximum time. D. Indira picks 3 workers at random from those who take longer than 25 minutes to travel to work. Calculate the probability that one worker takes 60 minutes or less and the other 2 take each more than 60 minutes. Alright, first thing we know in the question, she chooses 3 workers from those who take longer than 25 minutes. So we just ignore the first two bars completely and we take the next three bars, or we take these three here. So the probability is not going to be over 180 of the selection chance. It's going to be over the sum of those three, which is 107. So greater than 25 minutes. So T is greater than 25, 107 people or workers. And the probability that one worker takes 60 minutes or less. So 60 minutes or less is going to be in these two out of the three. So 57 plus 38. 57 plus 38. And of course, we're dividing by 107. Multiplied by the probability for the other two. It is greater than 60 minutes, which is this, that's 12. And this time over 106. Why over 106? Because we have already taken out one person, which is the one who takes 60 minutes or less. So the other two, it'll be 106 people left and then 105 people left. And the numerator will be 11, since you've already chosen one person from this group, from the group with more than 60 minutes time taken. And this 57 plus 38, by the way, is just going to be 95. And of course, we have to multiply this by 3, because we have 3 different orders of how we can get this people. So let's say we label the people that take more than 60 minutes with the number 2. And we label the person who takes 60 minutes or less as number 1. How many ways are there to order this 1 and 2s? There's 1, 2, 2, 2, 1, 2, and 2, 2, 1. So there are 3 ways to order them. That's why we multiply by 3 for 3 different orders which they could be chosen. And therefore we can just simplify all of this. 653. This will cancel here. And this 35. And now 35 and 95, this will become 7. This will become 19. Now, we cannot simplify anymore. We just go ahead and multiply everything out using our calculator. So we can get a calculator out. 19 times 6 times 11 to get 1254. And the denominator will be 107 times 53 times 7, 39697. This is simplest form, and that'll be our answer. Now we can go to question number 6.